Welcome to Python, Fashion MNIST classification. In this lesson, you will learn Python basics and build a simple image classifier using TensorFlow Keras. We will use Fashion MNIST, a dataset of clothing item images and labels. No prior coding experience is needed. Let us get started. Running the cell now. We begin by importing tools we need. This comment tells us what will happen. We bring in the warnings library, which lets us hide warning messages. This line turns off all warnings. That keeps our notebook clean. We print a message to check that things are set up. Printing shows a message in the notebook. Running the cell now. Try running this yourself. If you see the message, you are ready. What is Fashion MNIST? Fashion MNIST is a collection of 70,000 images of clothes, shoes, and bags. Each image is 28 by 28 pixels and is labeled with its type, like sneaker or shirt. Running the cell now. Now we will load the Fashion MNIST data into Python. This comment says what this cell does, it sets up the data. We import Fashion MNIST from TensorFlow Keras. This library makes deep learning easy. The data comes in as for groups. X holds the images. Y holds the labels. Train is for learning, test checks if the model works. Here we show the shape. That means how many images and how many labels we have for training. This line prints out the same for the test set. Running the cell now. Check that the shapes match what you expect, 60,000 for training and 10,000 for testing. Next, let us look at an image from the dataset. This comment explains we will look at data. We import a tool for making pictures, Matplotlib. This shows the first image in our training set, using grayscale colors. We set the title to show the label number. Each label is a number for the type of clothing. This hides axis lines so the image is cleaner. We display the image. Running the cell now. Try changing the 0 to 1 or 2 to see more images. What kinds of items do you see? Python basics. What is a variable? In Python, a variable stores information for you, like a box with a label. You can use variables to save numbers, text, and even images. Running the cell now. Let us try making our own variables. This comment guides us. We store a person's name as text. Text in Python uses quotes. Here, we save a favorite number. Numbers do not need quotes. This prints out the name. Print shows a variable's value. This prints out the favorite number. Running the cell now. Try changing the values and printing again. You can store almost anything in a variable. Let us learn what types our variables are. Type means the kind of data. We asked Python for the type, using the type function. This tells us if it is text, which is called string in Python. This tells us if it is a number. Numbers are called int, short for integer. Running the cell now. Knowing types helps avoid mistakes later. Lists, storing many things in one place. A list is a way to keep several pieces of information together in one variable. You use square brackets and commas to make a list. Running the cell now. Let us make a list of some clothing items you might see in Fashion MNIST. This comment tells us what is next. We store for clothing item names in a list. Each item is separated by a comma. Printing shows the list. Running the cell now. Lists help you keep related items together. You can add or remove things later. Now we will select specific items from the list. In Python, indexing starts at 0. This guides us to pick parts of the list. This gets the first item. The number in brackets is called the index. This finds the last item by using -1. Negative numbers count from the end. Running the cell now. Try picking other positions, like items 1 or items -2. Let us see what happens if we try to get an item that does not exist. This comment warns us about a common mistake. Here, we use a try except code block for safety. Try means Python will attempt this code. If a problem comes up, we catch it and handle it. If there is an error, this catches it and lets us decide what to do. We print a friendly error message. Out of range means the index does not exist in the list. Running the cell now. If you see an index error, do not worry. It is a common mistake that can be fixed by checking list size. Modifying lists, adding and removing items. You can change lists by adding new items or removing old ones. This lets your programs adjust as you go. Running the cell now. Let us add a new item and take one out. Comment shows we will change the list. This adds boot to the end. Append means add to list. This removes dress from the list. Now we print to see what has changed. Running the cell now. You can use append to grow your list and remove to delete unwanted items. Let us find out how many items we have now. Comments help us explain. The len function counts the number of items in the list. Len means length. Running the cell now. Knowing the length helps you avoid errors when looping or picking an item. Loops let you do something for each thing in a list. They are very useful in Python. This sets up a loop. For each item in items, the code below will run. Inside the loop, we print the name of the item. The colon tells Python to run the code below each time. Each fashion item is printed one at a time. Running the cell now. Try adding more things to the list and see how the loop prints each one. Fashion MNIST uses numbers for labels. Let us map those to clothing names. We create a list of 10 names, one for each class in the dataset. First label is t-shirt or top. Second label is trouser. Third label is pullover. Fourth label is dress. Fifth label is coat. Sixth label is sandal. Running the cell now. Check which number matches your favorite item. Knowing the mapping is important for understanding predictions. Before we train a neural network, we need to prepare the image data. This comment says we will make data ready for modeling. Here we divide each pixel by 255.0. That makes values go from 0 to 1 instead of 0 to 255. Models learn better with small numbers. We do the same for the test dataset. Running the cell now. Scaling is important for neural networks. Try printing x_train_scale.minute and max if you want to see the range. Let us build and look at a simple neural network for classifying images. This sets up a comment for this chunk. We bring in modules for building and stacking layers in the model. We start a model as a sequence of layers. Flatten turns each 28 by 28 image into a long row. This helps the model process the data. The first dense layer has 128 units and uses ReLU activation, which helps the model learn patterns. The last dense layer has 10 outputs, one for each class. Softmax means the output is a probability for each label. We finish building the model here. Now we set up learning details. Adam is a popular optimizer that adjusts how the model learns. The loss function is for classification. Metrics track how well the model is doing. This prints a summary, showing input, output, and layers. It is helpful for checking the structure. Running the cell now. Look at the summary. See how many weights and layers we have. Every neural network is a stack of simple pieces. Now we teach the model to recognize clothing. Training means showing it many labeled images. This line signals we are starting training. We call model.fit to start training. It learns with our scaled images and labels. We train for 5 epochs. That means the model goes through all the training images 5 times. Batch size tells how many images to learn from at once. We use 32 here. Validation split keeps 10% of data to check our model's progress. Running the cell now. Watch how the accuracy changes. Did your model improve over time? Let us see how well our model does on new, unseen data. This comment signals evaluation. We call the evaluate method to test our model. We use test images and labels. Printing the accuracy shows how often the model gets the right answer. Running the cell now. If the accuracy is high, your model learned well. Aim for above 0.80, but do not worry if it is lower for now. Let us use our trained model to predict one test image. This comment says we are making a prediction. We import numpy, a library for numbers and arrays. Set img_index to pick which image to predict. 0 is the first one. We get the image from the test set and scale it. Model.predict gives a list of scores, 1 per class. We need to add a batch dimension first. Argmax picks the class with the highest predicted value. That is our model's best guess. We show the test image as a picture. The title shows what our model thinks the item is. We use the label names for clarity. Axis lines are hidden to keep the plot simple. Show the result. Running the cell now. Try changing img_index to test other images. How often does your prediction match what you see? Now, try picking an image yourself and see what the model predicts. We want the user to select which image to test. Ask the user to input an index. Input creates a prompt and returns a string. We change it to integer. Get the selected image and scale it. Predicts what the item is. We set verbose equals 0 to keep the output clean. Find out the predicted label as before. Print out the label the model thinks the image is. Running the cell now. Try different numbers to see the model's guesses. What happens if you pick a number out of range? Let us see how well our model does on a handful of images picked at random. This is a new challenge. We use random to pick test images. Import the random library to help us pick numbers. We will do this 5 times in a row. Pick a number from 0 to 9999 for a test image. Get the scaled image at that index. Find the true label using label_names. This is what the item really is. Use the model to predict the label for the image. Get the predicted class name. Print both the true and predicted label for each image. Running the cell now. Do the predictions look right? Sometimes models confuse similar items, like shirts and t-shirts. Mini project, build your own classifier. Now it is your turn. Try changing how many layers or neurons are in the model. Can you make accuracy go higher or lower? Experiment, then retrain the model and test again. Running the cell now. Let us try making the model deeper and see what happens. Comment describes the plan, bigger and deeper network. Sequential starts a new stack of layers. Flattens the image as before. Dense layer now has 256 units. That means more possible patterns to learn. New layer, dense 64 more units. Adding more layers is called making a network deeper. The output layer is the same, 10 units for 10 classes. Set up how to train, as before. Loss and metric are same as before. Train for 5 epochs, using the same settings. This can take a little more time. Test the model on the test set. Show the new accuracy. Did it go up? Running the cell now. Keep exploring. You can switch the numbers or use different activation functions for fun practice. Sometimes your model is not very accurate. That is normal when starting out. Comment for troubleshooting help. If accuracy is less than 0.7, this tip will help you improve. Friendly advice: train longer, change units or batch size. If accuracy is good, we print a compliment. Positive feedback helps you see progress. Running the cell now. If you get stuck, ask for help or try rerunning cells from the start. Practice helps a lot. After training, you may want to save your work. This hints at a helpful practice: model saving. Saves the whole model to a file called fashion_model.keras. File names ending in Keras are common for Keras models. You will see a message if saving worked, letting you know the file is there. Running the cell now. Try loading your model in a new notebook sometime. Saving helps you avoid retraining if you want to test new predictions later. Recap: what did you learn? You explored Python basics, variables, lists, loops, and built a neural network with real image data. You learned how to train, test, and predict with a TensorFlow Keras model. Experimenting and practicing is the best way to get better. Running the cell now. Try it yourself and subscribe. Practice with your own models and images. Try tweaking layers and settings. If you enjoyed this, like and subscribe for more beginner Python lessons. Ask questions in the comments below, and happy coding. Running the cell now.